Alright, what we're going to do now is we are going to apply that elimination process where we did it with two equations and two variables. We're going to apply it to a system of linear equations in more than two variables. So in fact, this is how computers use it for solving linear systems in any kind. Could be 5 variables, 5 equations. It could be 12 equations, 12 variables. So when you do this, the goal is to rewrite the system in a form in which you can use back substitution. And if you take a look at these two systems, notice the first one, we do indeed have 3 equations and we have 3 variables. Okay. And that one, you look at that and you might think, oh, okay, I don't remember how to start. I'm not sure what to do. Whereas I took the second, it's actually this same system, and I just applied the row echelon form to it, and I made it so that it looked like this. And when you look at this, you see, oh, well, that's fairly simple to solve because I already know what z is. So since I know what z is, I can substitute it, back substitute into the second equation. When I plug in the value for z, then I can solve it for y, and then I can take both of those two values and plug it into the first equation in order to find x. So the goal then is to get it in this row echelon form. And there's a little bit of a pattern to it. If you notice, it kind of has a stair-step design, and the leading coefficients are all 1. So 1x, 1y, 1z. So I'm going to show you how to take a system, and we're going to start off with this system right here. So let's go to the, actually this next screen, then I'll tell you about some of the row operations that we can do. And we applied these when we were solving a system of 2 equations. And one thing you can do is just interchange any 2 equations in a system. So like if you, the second and the third equation, you can just switch the order of them. You can multiply one of the equations by a number as long as it's not 0. So you can multiply through by a 2 and you're not changing the value of the equation. Or you can change all of the signs. Or you can divide by 3. Okay, another thing you can do is after you multiply the equation by some number, you can add it to another equation and then replace that equation with it. Okay, so these are our approved row operations. So then let's see how this works. I want to put it in that row echelon form, and the process, I hate it when I do that. The process that you go through to get it in that form is known as Guassian Elimination, and it's just named after a mathematician, Carl Gauss, and so they credit him with figuring this out. And we want to then take a look. We want to take one of the equations, and it doesn't matter which one we start off with, but what we're looking for is a coefficient of 1 for the x. And we want to have all 3 variables. Well, this first equation already has exactly what we need. Okay, so there's our first one. It's all ready to go. Now what we want to do is in the next equation then, we want to eliminate the x so that we have just a y and a z. So we want to get rid of, and we're going to move from the left to the right. So we're going to get rid of the x. Well, let's say I'm going to take this second equation. It has a negative x. So the easiest thing is going to be to add it to the first equation. So when we add these 2 equations together, the x's cancel. We get a positive 1y plus 3z is equal to 5. Okay, now there's my second one already, because now I have the 2 equations, or I have that one equation in 2 variables, and the coefficient of the y is 1. Now I'm just going to go ahead and take a step, and I'm going to write these both down here. So here's my first one. And normally you aren't going to go to all of this work. I just want to make sure that when you're learning this process that it makes sense. So you see our stair step beginning to build here. Okay, now the goal now is to use this third equation, and we want to get rid of the x and the y, and we're going to get rid of the x first. Alright, so if I have a 2x here in this third equation, I want to eliminate that x, so I can add it to either one of the first two equations. Well, if I just added them right now, the x wouldn't cancel. So I'm going to multiply one of the first two equations. And let's just say, let's take the first one. So I'm going to multiply the first equation then times a negative 2. So maybe I'll put it here. So negative 2x plus 4y minus 6z is equal to negative 18, and I want to add it to the third equation because our goal is to get those x's to cancel. And when I add those, the x's do indeed cancel. I get minus y minus z is equal to negative 1. Okay. Now that I've got the y to cancel, now I want to, now that I got the x to cancel, now I want the y to cancel. Well, take a look at these two equations that we have in y and z. And notice if I just added those two together, right the way they are, the y's will cancel. So when I combine, I get 2z is equal to 4. And I don't want just a 2z, I want a 1z, so I'm going to divide by 2. And there is our third equation. Okay, so I'm going to rewrite it over here. So now I have that row echelon form. Now we can simply use back substitution and we will have our solution. So we're looking for the ordered triplet x, y, and z. We know the z is 2, so that's the third variable. So remember, we're going x, then y, then z. It always goes alphabetically. Then we take that value for z and we plug it in to that second equation and find out what the y is. So 3 times 2 is 6. So y plus 6 is equal to 5. Oh, gotta go. Got a phone call. Okay, well, I'm skipping on. I can't go back and edit that. I can't get back to that screen. So I'm just going to write up here what we had. We said that z was 2. And then we had, or we're getting close to saying that y was negative 1. So now if we take both of those and we substitute it back into our first equation, we're looking for x. Y is negative 1, so negative 2 times negative 1 is plus 2. And z is 2, so 3 times 2 is 6. So x plus 8 is 9. So therefore, x is 1. So here is our ordered triplet. Whoops, y first, negative 1, and then the z of 2. Okay, that's ugly. 1, negative 1, 2. So there is our solution. And if you would check to see if it's correct or not, then you plug all 3 of those values into all 3 of the equations and you get true statements. Okay, let's go on to another one. We're going to take this one, we're going to do row echelon form. So the goal is to have the first equation in all 3 variables and the leading coefficient is 1. Well, we got the first equation, so we're ready to go. I want the x's to cancel now, so let's take a look at this second equation. I want to get rid of that x. I've got a 2x, so it'd probably be simplest to multiply the top equation by negative 2 and then add them together. So we get negative 2x minus 2y minus 2z is equal to negative 12. Add it to the second one, so we don't have to do anything to that second one right now. And combine. The x's cancel. Negative 3y minus z is equal to negative 9. Alright, so we got rid of the x. Now what we want to do is get a 1 coefficient in front of that y. Well, to get a 1, we just have to get rid of that negative 3. So we're going to divide through by negative 3. So this whole equation divided by negative 3 will give us y plus 1/3 z is equal to positive 3. So now we have our second equation. Now we're going to go to the third equation. We want to get rid of the x and the y. Well, the y is already gone, but sometimes when you get rid of the x, the y will reappear. And I have a 3x here, so I want to find the easiest way then to get rid of the x. So I'm going to combine it with the first equation again, only this time I'm going to take it times a negative 3. Let's just multiply it by that negative 3 and write it right below this equation here. So negative 3x minus 3y minus 3z is equal to negative 18. Multiply it all the way across. When we go to add, the x's cancel. I have negative 3y minus 4z is equal to negative 18. Well, now that we got rid of the x, we want to work on the y. So I have this equation in, let me see, in y and z. And then I have these two equations, this one here and this one here, before I divided. Well, we want to get rid of that y, so let's go back to this guy here. And we want to combine these two so the y's will cancel. Well, they're both negative, so let's just change the sign. Let's change the sign on this one up here and put it below. So I want a positive 3y plus z is equal to positive 9. And then when we add those, the y's cancel. We get negative 3z is equal to negative 9. And I want a positive 1z, so we go ahead and divide. So we get z as 3. So that is our third equation. That now, if we listed them, would be in row echelon form. So I have x, y, z in this first equation, a coefficient of 1. I have y and z in this one, a coefficient of 1 for the y. And I have just z and a coefficient of 1. Okay, so we're ready to do back substitution. The z value is 3. I take that, I plug it into this equation with the two variables. A third of 3 is 1. If y plus 1 has to equal 3, then y must equal 2. And then I take those two values and plug it in to that first equation then to figure out what the x is. So x plus 2 plus 3 is equal to 6. So x plus 5 is equal to 6. So therefore x is 1. And there we have our solution. Now let's take a look at this. Now what we're going to do is like a curve fitting activity where we use that row echelon form. And we want to write the equation of a quadratic. So remember, a quadratic looks like this. In order to write that equation, we have to know three values. We have to know the value of a, b, and c. Well, in order to solve for three variables, we have to have three equations. So we take the points that we have, and let's take this first one here. So when x is equal to -1 and y is equal to 3, we can plug those values into the equation, and we come up with the equation 3 is equal to a. We're taking out the x and replacing it with -1. And we're also taking out the x here and replacing it with -1. And that gives us one equation. And the equation ends up being a minus b plus c is equal to 3. So the -1 squared gives us 1. 1 times a, we get a 1a. Alright, now we're going to do the same thing with this point. When x is 1 and y is 1, we end up with 1 is equal to a times 1 squared plus b times 1 plus c. So if I simplify it and rewrite it, I get 1a plus 1b plus 1c is equal to 1. And then our last one, we're going to plug in the 6 for the y and the 2 for the x's. So we get 6 is equal to a times 2 squared plus b times 2 plus c. So that gives us 4a plus 2b plus c is equal to 6. Okay, so that is our system of equations. So let's just rewrite it over here. A minus b plus c is equal to 3. Gosh, I hope I don't run out of room. And the last one, okay, so we're going to put it in row echelon form. I can either keep the first equation or I can swap it out with the second one. Let's just keep the first one. That means now my second equation, I want it to be in b and c. So I want to get rid of the a. So the easiest thing to do would be to keep this one the same and multiply this one times a -1, so it will cancel out the a. So -a plus b minus c. Have to make sure and change all of the signs. If I'm distributing a -1, all of the signs change. The second equation, we're going to keep the same. When I add those together, the a's cancel. Oh, but so do the c's. So I get b is -1. Well, that kind of foils my plans of getting it in row echelon form, but it's not all bad because what I have right now is the value for one of the variables. Remember, we're looking for a, b, and c in that order, and we already have the b value. So we'll plug in a -1 here. We need to then, because this row echelon form isn't going to work, what we need to do though is have an equation with a b and some other variable in it so that we can do a back substitution. I have not used the third equation yet, so it's going to be important to incorporate this third equation. So on this equation then, with the 4a plus 2b plus c is equal to 6, I want to eliminate one of the variables. And I don't want to eliminate the b because I know what b is. I want to be able to substitute it in. So I have to eliminate either the a or the c. Well, I think it's going to be easier to eliminate the c because I have a 1c there. And the equation right above it, both equations actually have a 1c. So let's keep the third equation looking the same. And I am going to combine it with the second equation. So if I want that c value to cancel out, I have to multiply the second equation times a -1. So that'd give us -a minus b minus c is equal to -1. We combine, the c's cancel, we get 3a plus b is equal to 5. Now I can start my back substitution. Since I know what b is, I'm going to take out the b and replace it with -1. So 3a minus 1 is equal to 5. So I get 3a is, I'm running out of room here. So I get 3a is 6. So a is 2. Now that I know it, I can go back to any one of the first three equations, and substitute in both of those to find a c. Let's go back to this one. Okay, we know a is 2. I want to subtract b, which is -1, plus c is equal to 3. So 2 minus -1 is +1, so it's 3. That means c is equal to 0. Okay. So my equation then, if we plug this in, let me put this here. Here's my 2, my c is 0. But the goal of this was to find a quadratic equation, so I'm not quite done here, like I was with the other ones. So then I want to go back up to my quadratic and fill in for the a, b, and c, so then we get our equation. So y is equal to a x squared, a is 2, so 2x squared, plus bx, b is -1, so minus x, and then c is 0. So now this is my final answer. That's the quadratic equation, and it passes through all three of these points. And you can substitute in and check it out. Make sure that I didn't make a mistake. Okay? Now, this is what I want you guys to do. I want you to see if you can apply that knowledge to these two problems, number 6 and number 14 on page 527. Okay? So, good luck doing that. If you have questions then as you're working through that, please bring them back to class. All right, see you soon.